Okay, so this is example 36 then. What page are we on here? 132. So example 36, page 132. Okay, so we've got two vector equations of lines L1 and L2. So the first one, so we'll call that R1. We can rewrite that as 3 plus lambda and 1 minus 2 lambda and 1 minus lambda. This is a position vector. This will give us the position vector of any point on R1. So R2 is going to be, now we've got to be careful here because we've got no I component. So basically the first one is just going to be minus 5 mu. And then we're going to have minus 2 plus mu. And finally 3 plus 4 mu. And that obviously gives us any position vector on R2. So if we're looking for a point of intersection, then R1 is going to be equal to R2 at a point of intersection. So therefore, 3 plus lambda is going to be equal to minus 5 mu. 1 minus 2 lambda is going to be equal to minus 2 plus mu. And 1 minus lambda is going to equal 3 plus 4 mu. Okay? Now, obviously, we've got two variables, so we've got to solve simultaneously. Etc. Okay, so what I did, I rearranged this one, and I chose to say that this one, for this one, 3 minus 2 lambda is equal to mu. Okay, so if we call this 1 and this 2 and this 3, so then I substitute 3 minus 2 lambda is equal to mu into equation 1. Okay, so 3 plus lambda is equal to minus 5 times 3 minus 2 lambda. So that, when we finish working it out, is going to give us lambda is equal to 2. Okay, so then we're going to have to find mu, and to find mu, I substitute lambda is equal to 2 into equation 3. So 1 minus 2 is equal to 3 plus 4 mu, and that gives me mu is equal to minus 1. So I've got my I've got my lambda and my mu now. So what I have to do now, I haven't finished, because what I have to do is I have to now find the point of intersection. So these are back to the vector equations of the lines then, which I've wrote down here. So basically what we've got to do is we've got to substitute the values of lambda in. So when lambda is equal to 2, position vector that we're going to get is 3 plus 2, which is 5, 1 minus 4, which is minus 3, and 1 minus 2, which is minus 1. And in R1, where mu is equal to minus 1, we're going to get minus 5 times minus 1, which is 5, minus 2 minus 1, which is minus 3. That's 5, by the way, not minus 5. Okay? And 3 minus 4 is minus 1. So the point of intersection is, the point of intersection, remember, we've got to give it as a point, is going to give us 5 minus 3 minus 1. Watch out for that. Point of intersection, you've got to write it like coordinates. Okay?